Breaking the wall of coronary artery disease. Qualified in the Athens lab, Sotiris Evgenidis, Aristotle University of Thessaloniki, Greece.
Ladies and gentlemen, coronary artery disease is the most common use of death globally, representing almost 17% of deaths each year. It has to do with the blockage of the arteries that supply with blood the heart, and until now, the most reliable method for the diagnosis is the invasive coronary angiography. Our goal is to break the wall of the detection of coronary artery disease, developing a non-invasive method for use at home. Until now, in clinical practice, an ultrasound method has been applied that applies an ischemic cuff on the left hand in order to investigate the blockage of the brachial artery that is strongly correlated to that of the coronary arteries. But this method has several disadvantages, like poor repeatability, bulky, it needs bulky and expensive equipment and also it is strongly dependent on ultrasound operator. On the other hand, we suggest a novel technique of electrical impedance spectroscopy technique of high accuracy and sensitivity that needs small and portable equipment that is very easy to use. Also, the cost is affordable to use at home, and moreover, we can combine it with telemedicine application for use in remote areas such as small islands. So our approach is based on measuring, on studying the blood flow in the brachial artery and before and after the ischemic cuff. So we place 2 electrodes. Okay. So we place 2 electrodes at this area, and we start making our measurements. And after a while, we apply an ischemic cuff on this area, and we see that the signal increases. But not only that, because we see that the behavior is completely different for healthy and non-healthy people whose arteries are blocked. When the ischemic cuff is finalized, when the signal decreases due to vasodilation, but also the transition differs a lot for the 2 cases. It should be strengthened that the proposed technology is actually a technology transfer from space technology that has developed the last 10 years from multi-phase dynamics group in Aristotle University of Thessaloniki as regards for the diagnosis of decompression sickness in astronauts for the needs of European Space Agency. Thank you.
Yes.